Hey, fifth graders, we are on our new module, Module 2, Lesson 1 problem set. In this module, we're going to be doing some big number multiplication as well as some long division. So, on this lesson, you hopefully at the end can multiply multi-digit whole numbers by 10, 100, or 1,000. So we're going to be working with multi-digit only whole numbers, no decimals in this lesson, and we're going to be kind of going back to module 1 and multiplying it by 10, 100, and 1,000. So let's get started. All right, here we go, guys. Number 1, they want us to fill in the blanks. So let's box that in. Using our knowledge, what we know about place value units and basic math facts. So let's look at 1A. 1A is 23 times 20. And so what they did is they changed 23 to be unit form. So it's 23 ones. And then they changed 20 to be 2 tens. And so right now we're going to think about if we have 23 ones and we're going to multiply it by 2 tens, let's just multiply 23 times 2. That's like taking 23 and doubling it, and we should get 46. Now, in red, we're taking the word ones and multiplying it by tens. Well, the word ones times tens, it will give us the unit form of tens. And so now we have 46 tens. 46 tens would mean we got to put a 0 at the end of 6 to make it 460. Because 446 tens is the same thing as 460. So for B, they did 230 times 20. And so we went ahead and changed it to be 23 tens. That equals 230 times by 2 tens, which equals 20. So we are going to just multiply the 23 and the 2. That was 46. And now we're going to multiply the tens times the tens. What word would we get for the unit? That would be hundreds. So let's write the word hundreds next to 46. And so 46 hundreds would mean how many zeros are in 100? There's going to be 2, so we're just going to add 2 zeros to the end of 46. So it's 4,600. So for C, 41 times 4, what they did is they did 41 ones for us, and they did 4 ones for us in unit form. They actually gave us the answer of what 41 times 4 is, and that's 164. So what we need to figure out is what does ones times ones in unit form or in word form. 1 times ones would be ones. So we have 164 ones. Are there any zeros in the number 1? Nope. So that means the answer is going to be 164. 1D, they did 410 is the same thing as 41 tens. And 400 is the same thing as saying 400s. And so once again, they gave us the answer of 41 times 4 is 164. We need to figure out what does tens times hundreds equal. You can also think about tens as just the number 10 and hundreds as the number hundreds. So what happens when we multiply these two numbers together? That would give us thousands. So we're going to write the word thousands. And now we're going to go ahead and figure out how many zeros are in 1,000. There's going to be 3. So that means we're going to write 164 and then add 3 zeros. So our answer is 164,000. Let's look at 1E. So we have to actually convert 3,310 into how many tens? Do me a favor. Put a 0 above the word tens because there's 1 0 in 10. So what that means is we get rid of the 0 here, and in unit form, we would have 331 tens. Same thing with hundreds. There are 2 zeros in hundreds. That means take away these 2 zeros, and you're going to have 3 hundreds. So they gave us 331 times 3 is 993. And now we got to figure out what is tens times hundreds. Like the last problem that we just did, it's going to be thousands. So we'll squeeze that in. So that means how many zeros are in 1,000? There's going to be 3. So we're going to add 3 zeros on the end of 993 to give you 993,000. And the last one on this problem, 500 times 600. So we already have hundreds. So how many hundreds do we have in the first number? We have 5. And then we're going to multiply that by 600s. Well, 5 times 6 is 30. And so hundreds times hundreds. So if I wrote the number 100 underneath the word hundreds, same thing over on the other side. 100 times 100 would give you 10,000. So that means we're going to have the number 30, and we're going to go ahead and add how many zeros are in 10,000. That's going to be 4 zeros. 1, 2, 3, 4. And me putting my comma after the 30 was not a smart idea, so I need to erase that. Go ahead and erase the whole number again. Try it one more time. So I'm going to put 30 and add my 4 zeros. 1, 2, 3, 4. And my comma in blue is actually going to go right there after the second 0. So number 3, they want us to find the products for each problem, and they want us to show our thinking. The first row gives us some ideas on how to show our thinking. So we're looking at this row right here. This is a kind of example that we're going to look off of. So let's go ahead and do 3B. And so let's go ahead and figure out what 45 times 3 is. Going back to 4th grade math, 3 times 5, that's 15. And then 3 times 4, that's 12, and add one more, that would be 13. So that would be 135. Now, for the second part of B, what we're going to do is we're going to be breaking up some of the numbers to make them be a little bit easier to multiply. So first of all, 45, we're going to keep that the same. We're not going to break it up. But we are going to break up the 30, and we're going to break it up by doing 3 times 10 and put that in parentheses. And now we're going to kind of change the way we want to multiply. Next, we're going to multiply 45 times 3. Put that in parentheses because that tells us that we're going to do that first, and then we're going to multiply by 10 second. So then we already know what 45 times 3 is. That was 135. And we're going to be multiplying it by 10, which means it's going to get 10 times bigger. That means we're going to add a 0 to the end of 5 to give us 1,350. Now I'm going to draw a little line to separate the next problem that we do. We're going to take 450. This one I am going to break up because I'm going to say, okay, I'm going to take 45, and I'm going to say that's the same thing as 45 times 10 would give you 450. And then I'm going to multiply 3 times 10 because that would give you 30. Now I'm going to change the numbers up, kind of like we did in the previous problem. We're going to do, okay, 45 times 3. I'm going to do that first. And then I'm going to multiply the 10 times the 10. So let's go ahead and figure out 45 times 3. Well, that's easy. We already have all the work on the left. That's 135. And now we're going to multiply 10 times 10. That's 100. And so now all we're going to do is we have 135 hundreds. That's what 135 times 100 means. So that means we're going to do 135 and add 2 zeros to the end to get 13,500. And the last one for 3B, same thing. We're going to do 45 and break that apart. That's going to say 45 times 10. And then we're going to break up 300 and say that's the same thing as 3 times 100. We're going to change the way we order our multiplication sentence and say let's do 45 times 3 first. And then we'll go ahead and multiply the 10 times the 100. Well, 45 times 3, 135. And then we're going to multiply the 10 and the 100 together, and that would give you 1,000, because that would be 3 zeros. And so that means we're going to take 135, and we have 135 thousands, so add 3 zeros to the end. So our answer becomes 135,000. Don't forget, if I'm going too fast for you, you have the option to pause and to get caught up. And when you're ready to move on, just hit unpause and follow with us. All right, let's do 3C. We're going to take 40. We're going to break that up. So that's going to be the same thing as 4 times 10. And then we'll multiply it by 5. Let's change the order around. And let's say, hey, let's multiply the 4 and the 5 together. And then we'll multiply the 10 last. So 4 times 5 is 20. And then you're going to say, and multiply it by 10. So you have 20 tens. 20 tens also means 20, and add a 0 to get 200. All right, same thing with 40 times 50. We're going to do, okay, let's break up 4 times 10 will give us 40. And then we have 5 times 10 will give us 50. I'm going to try to squeeze this in the best I can. All right, we're going to change it up a little bit. 4 times 5. And then do that first. And then we do the 10 times the 10. So 4 times 5 was 20. And then we're going to multiply it. 10 times 10 is 100. So this represents, right here, this represents 20 hundreds. So you put 20, and how many zeros are in 100? There's 2. So 20 times 100 turns out to be 2,000. So on this one, I'm going to show you a little bit of a a little bit of a different way of writing it. It's going to be less writing, but it's going to just show our thinking. We have a basic math fact of 4 and 5. We already know that that's 20. So I'm going to say, okay, 4 times 5 is 20. And then I have a 0 in the 40 and 2 zeros in the 500. Well, what number, 10, hundreds, thousands, 10,000s, 100,000s, one of those numbers have 3 zeros? And that's going to be the number 1,000, because it has 3 zeros. And so 20 times 1,000 would be 20,000. That means you put a 20 and you add the 3 zeros behind it to get 20,000. So I kind of eliminated some steps, but it's still showing my thinking. Same thing with this one over here. 4 times 5, that's going to be 20. Basic math fact. And we have 2 zeros. That represents 100 in 400. And we have 3 zeros. That represents 1,000 in 5,000. So if you add those numbers zeros together, that's going to be 5. What number, 10, 100, 1,000, 100,000, 10,000, have 5 zeros in it? That's going to be 100,000. That has 5 zeros. So we have 20 times 100,000. That's 20 100,000. So we're going to write 20. And we're going to add the 5 zeros. 1, 2, 3, 4, 5. And let's not get caught up. 20 already had a 0 in it. You have to add 5 more zeros after 20. So we're not including the first 0 after the 2 in the 5. We need to add 5 more, because then this turns out to be the answer of 2 million. And let's do D. Let's go ahead and figure out what is 718, multiply it by 2. So you can either multiply it by 2, or you can just add it twice. That's the same thing. So I'm going to add it twice. You might multiply it twice, or multiply it by 2. So make sure you show your work. 8 plus 8 is 16. 3 or 1 plus 1 plus 1 is 3. And then my 700s plus another 700s would be 1400. So that is 1436. So since I already know what 718 times 2 is from the first part that we just did, that is 1436. Now I'm going to figure out what am I going to multiply. Well, there's one 0 in 7,180, and there's another 0 in 20. So the number that represents two zeros would be 100. And so I would take my 1,436 and add my two zeros to give me 143,600. Same thing with the next one. 718 times 2, I just figured that out. That was 1,436. And then it looks like I have 1 0 in the first number, 2 zeros in the second number. So the number that represents 3 zeros would be 1,000. That means I take my 1,436, add 3 zeros to get 1,436,000. And then we'll go ahead and you guys hopefully are seeing the patterns that we're doing. We'll go ahead and skip this last one and go over to some word problems. All right, guys, let's look at number 4. And number 4 is kind of an interesting problem. Riley told his mother that multiplying whole numbers by multiples of 10 was easy because you just count the zeros in the factors. And by the way, factors are the numbers you're multiplying together. And put them in the product. Product is actually the answer to a multiplication problem. He used these two examples to explain his strategy. Well, let's look at his strategy. 7,000 times 600 equals 4,200,000. Well, I'll tell you that 7 times 6 is 42. So he's right. So there's 3 zeros here, and there's 2 zeros here. So that means there should be 5 zeros in behind 42, which he's correct. So this is correct. Over here, 800 times 700 is 560,000. Well, I'll tell you that 8 times 7 is the basic math factor of 56. There are 2 zeros in 800 and there's 2 zeros in 700. So that means there's 4 zeros in 560,000. So this is correct. So it looks like Riley has two problems that actually prove that his theory is correct. But then his mother comes in and says, you know what? Your strategy, Riley or Ripley, will not always work. Why not? Give an example. So we got to think of an example that proves that Ripley's theory is not correct. So maybe some of you already are thinking, hey, I kind of have an example that we did on the previous pages that we can use. Some of you might not catch on to this. So let's go ahead and just start exploring. Now I'm going to go ahead and write 40. And I'm going to times that by 500. And so I'm going to kind of use the same Ripley's example. Okay, well, there's 1 0 in 40. And there's 2 zeros in 500. So if we're following Ripley's theory, that our answer should probably have 3 zeros in it. So let's go see if we can prove him wrong with this problem. Basic math fact of 4 times 5. Well, 4 times 5 is 20. And now we have to take my 1 0 and my 2 zeros, which gives us 3 zeros, and we have to add it to the end. Now I'm not going to count the 0 that I already have in 20. I need to add 3 more. And so I get 20,000. Well, how many zeros do I see altogether, including the 0 and the 20? I have 4 zeros. So this actually proves that Ripley is not correct with his thinking. For most of them, he is, but for these examples, he's not correct. For this example, he's not correct because the 4 and the 5, when you multiply them, it ends in a 0 already. So another example would be 6,000 times 500, because 6 times 5, a basic math fact, is going to be 30. And then we have 3 zeros here, and we have 2 zeros here. So that means we need to add 5 zeros to the end of 30. 1, 2, 3, 4, 5. And that would give us 3 million, which means there are how many zeros altogether? 1, 2, 3, 4, 5, 6 zeros. So this proves that Ripley's understanding trick doesn't always work with certain numbers. And those numbers are actually the numbers that actually would give you a 0 in the basic math fact of 4 times 5 or 6 times 5. So this is our work that's going to support the question, because they want us to give an example. So why not? And here we're proving it with our work right here. And the final one for this lesson is number 6. So let's go ahead and mark that up and read it. Tickets at a baseball game are $20 for an adult and $15 for a student. A school buys tickets for 45 adults and 600 students. How much money, question says, will the school spend? All right, so we got some couple steps to find the final answer. We're not going to get this done in just one step. So we need to know that there's going to be 45 adults. And that means I'm going to take 45 and have to multiply it by $20. And then we have 600 students, and I'm going to have to multiply that by $15. And then at the end, you should know that we're going to add our two numbers to get the final answer to answer the question. All right, let's think about this. We got 45 and we got 2. So think of it as 45 doubled, 45 plus 45. That's going to be 90. And then we're going to multiply that by that 0 represents the number 10. So that would equal 90 tens is also $900. Let's go over to figure out what 6 times 15 is, because that's a basic math fact, or not really basic, but we can quickly do that multiplication fairly easy. We have 15 times 6, well 6 times 5 is 30, and then 6 times 1 is 6, plus 3 more is 9. So we have 90, and then we got to figure out, okay, well, what number represents those two zeros and 600? Well, that's going to be 100. So we have 90 hundreds. So we're going to write 90 with 2 zeros at the end. So that's $9,000 for the students. And so how much money do they spend on for the tickets? Some of you are like, oh, I can quickly do that in my head, but let's show our next step. Our next step is taking $9,000 and we're going to add $900. And then we're going to say that's going to turn out to be $9,900. And then we can write our sentence out. The school spent $9,900 on baseball game tickets. Period. So hopefully your penmanship is a lot neater than mine. Trying to write on an iPad is kind of difficult, but make sure you're putting your best work out there and you have a complete sentence and you have an ending punctuation. And that concludes our first lesson of Module 2. I'll see you on the next one.